Today we're going to look at different types of muscles. Smooth muscle is different than skeletal muscle. Smooth muscle gets its term from the fact that they are long, they're elongated, they have tapered ends. The smooth muscle comes from the fact that they lack striations. They don't have lines basically that show up. They are smooth. Sarcoplasmic reticulum is not quite as developed. So the myosin and actin molecules are going to cross bridge a little bit differently than in skeletal muscle. Therefore, you don't see striations during that cross bridging. So multi-unit smooth muscle, visceral muscle are the two types of smooth muscle. Multi-unit, that would be examples such as your blood vessels. So these are going to be found in your blood vessels, iris of the eye, and fibers that are separate. They don't occur in sheets. So a multi-unit smooth muscle, your blood vessels are going to work on their own. So smooth muscle is also called involuntary muscle. In my blood vessels, they are going to contract without me thinking about it, making it happen. Visceral smooth muscle, here again, involuntary. These occur more in sheet-like origination. They're found in walls of your hollow organs, so stomach, intestines, pancreas, in many of your organs. And what happens is these fibers stimulate one another, and they're going to have a rhythm, a rhythmicity, and they're responsible for peristalsis, which pushes food and digested material through your hollow organs and tubes. So here again, involuntary, my stomach churns and contracts without me having any knowledge of it. Smooth muscle is going to work on its own, and they lack striations. And here, like we said, the myosin to actin cross-bridging is a little bit different. There are similarities between smooth muscle and skeletal muscle. The neurotransmitters that they use are going to be the same. So acetylcholine and norepinephrine are going to stimulate and inhibit smooth muscle contraction depending on what muscle they're targeting. Other hormones can also stimulate or inhibit contraction. Acetylcholine being the primary one that I would like you guys to remember. Smooth muscle contracts slower and relaxes slower than skeletal muscle, but it can also contract for a longer period of time. It does not tire as easy, and it uses the same amount of ATP as your skeletal muscle does. So they're slower to contract, which really kind of is efficient when it comes to the amount of energy that they use. Smooth muscle can also change its length without changing its tautness or its tightness, which is important in the filling of organs such as the stomach. So when your smooth muscles contract, they don't shorten quite as much as a skeletal muscle does, which if your muscle or your stomach contracted like a skeletal muscle, we would not be able to eat very much because it would tighten so much when contracted. Cardiac muscle, another type of muscle. Cardiac deals specifically with your heart muscle, and that would be it. Branching, it has striations, so you're going to see lines under the microscope. They interconnect. By far the most branching type of muscle. The mechanism of contraction in the cardiac muscle is pretty much the same as skeletal and smooth, but there are a couple differences. Cardiac muscle has transverse tubules that supply extra calcium. And calcium ions are important in the movement and contraction of muscles. So because These tubules allow for more calcium. It lets your heart muscle contract for longer periods of time. Your heart muscle is one of the most strong muscles in your body. It works constantly, it works very steady, so therefore it needs that extra calcium to help it work all the time. Cardiac muscle is also self-exciting. There's an SA node that controls the rhythm of the heart, so that comes from within the heart. It's rhythmic and a very specific contraction and relaxation rate for your heart. If you hear of somebody that has an irregular heartbeat, then this pattern for some reason has been disrupted, and that's typically not a good thing. SA node, which basically self-excites the heart. If someone has a pacemaker, that has replaced their SA node. So heart, very rhythmic, constant contraction and relaxation, therefore needs extra calcium to keep it working all of the time. Also in heart muscle, we have intercalated discs, and basically they typically just excuse me, join the cells from one to another, and they are also going to help to transmit the force of contraction from one cell to another, aids with helping things move quicker. Back to that self-exciting part, when these cells are right next to each other, if I take heart cells out of a heart and put them on a petri dish, they will start beating on their own. And if you add more cells to that, they will start to beat in unison, beat in the same rhythm. So that rhythmic beat is very important for cardiac muscle. So last time we talked about skeletal muscles, and here's just a table that kind of goes over everything. Smooth and cardiac, here again, tables are a good thing to look over to kind of review before the next test. And that's probably where I will stop for today.